So now that we've learned the algebra we need for this unit, we need to talk about sequences. What is a sequence? Now, a sequence is any list of numbers that's put in order. And it's important that it's a set order that's going through. Here we have an order 3, 5, 7, 9. So the first term is 3. It has to be first. Second term, third term. 3 dots at the end means it goes forever or it's infinite. So a sequence is any set of numbers. It doesn't have to have a pattern, but it usually does. So for this unit, we're going to focus on ones that are mathematically, there's a pattern to them. So take the first example, 15, 25, 35. It's going up by 10 each time. Now it can go up, it can go down. Second sequence we have 80, 78, 76. We're counting down by 2. And the third one, we're actually doubling each time. 1, 2, 4, 8, 16. But again, a sequence is any list of numbers. It could be your favorite numbers. It could be the jersey numbers you've worn for soccer, whatever you want it to be. Now, one thing we want to go through is what happens if we don't know what number term it is. We call this the nth term. The nth term is a term that we don't know where it sits in order, but we know we eventually get there. So now we're going to get into sequences. Sequences is any list of numbers. Now, we've got an example here, 2, 4, 6. It's a pattern. We can see that it's going up by 2 each time. Notice that it doesn't have a dot, dot, dot. It's not going on forever. We call this a finite sequence. It will end, and we can see that in our list. The opposite is something that goes forever. Usually it has a dot, dot, dot at the end. Infinite sequence. Key thing here is we use the word term to represent each value in the list. So term 1 is 1. Term 2 is 4. So keep in mind, a lot of times we just abbreviate with the letter T. So term 2 is 4. The 2 is not a number that we use to calculate anything. Any number that's lower than the letter is just a description. It's saying that the second term is 4. This is what we calculate with. This is a description. Don't confuse it with something like t squared, which is a mathematical operation. So arithmetic sequences comes from arithmetic. We're adding or subtracting. So in this case, we can look at it and we see, oh, we go up by 4, up by 4. It's a constant amount every single time. Every time we go up a term, we're adding 4. We go to 7, 17, etc. It can also go down. It can be subtraction. 93 to 87, we're losing 6 units. 87 to 81, again, we're losing 6. If you're not sure, you can always check it. We always take a term and subtract the previous term. Doesn't matter where you do. 13 minus 9. If it's arithmetic, you can take 2 different sets and still get the same difference. If I take this one, I'll do 81 minus 7. It always has to be the later one minus the previous one. And in this case, it's negative, which makes sense because we're going down as we go through the list. Geometric has to do with multiplication or division. So you can see that we go up by 3, but then it's 6, then 12. So to find out how it's transforming, we're going to take one and divide by the previous. 24 divided by 12. If it's geometric, we can take any 2 terms. If we divide by the previous one, we'll still get the same ratio. It's going up by multiplying by 2. If I go to this one, I'm getting smaller. So if I put this in, I am multiplying by 0.25. Anything less than 1 is shrinking the numbers. I can check another one. And again, if it's geometric, we can take it to 2 or all of them, and it will have the same ratio compared to it. This one here is a little trickier. We've got fractions, and we can see that there's a pattern on top, 3, 4, 5, 6. So we can predict the next one will be 7. But it's not arithmetic because the fraction is kind of changing. It's getting weird numbers as we go along the bottom. Look at the bottom only, 2, 5. There is a pattern here. We're going up by 3. So even though it's a pattern on bottom and top, it's a recursive pattern because they're kind of separate. We're not adding the same amount each time. So the top has a pattern, the bottom, that is a recursive sequence. So now we're going to try and look at something and determine whether it's arithmetic, geometric, or recursive. So remember, arithmetic, we're adding the same amount each time. Geometric, we're multiplying or dividing the same amount. And recursive is some kind of pattern, looking at the past to determine the future. So right here, I see, it's going up by almost 20, and then it goes up by, again, almost 20. So let's just confirm. 41 minus 23, 18. We want to check the second one, 23 minus 5. And in this case, it's the same. So this is arithmetic because we're going up by the same amount each time. If we want to predict the next one, we add 18 and we get 59. This one here, we're going up by 6, but then we're going down. Up, down. So let's look at the numbers. Maybe there's a pattern in this that we can spot. We're going up by 6, down by 4. Up by, another up by 6. So these ones are going up 6 each time. This one's down 4. This one's subtracting 4. So we can see a pattern where we're going up and down. So this is a recursive pattern. So to predict the next one, we're going to add 6. We're going to get 12. Then we're going to subtract 4. And we get 8. And you'll notice we get 2, 4, 6, 8, 8, 10, 12. So a pattern there. So this particular case, we can see that the numbers are getting big really quickly. So what we're going to do is we're going to assume this is geometric because geometric gets large quickly. So to check, I'm going to take a term and divide by the previous term. I'm going to try this for another one. And because I've got the same number, this is the sign, we are multiplying by -7. This is geometric. This one here, it looks like a pattern. We're kind of multiplying by 2, by 3. But if you look closely, it's not getting faster. It's not changing. We're going up 11. We're going up 11. To confirm this. And then I'm going to check a second term to make sure it's arithmetic. In this case, it's got the same pattern, subtracting 11 each time. It is arithmetic.